Hello again, and welcome back to another episode of Adding Game Sounds, where today we're going to be looking at adding a looping sound to the moving platforms you can find around the 4th level of the 2D game kit we've been working on. I'm also going to be looking at a script I've written that will allow you to add looping sounds to nearly anything that moves, really. But before we look at all of that, I just want to quickly let you guys know that the FMOD and Unity Essentials course is going to be returning soon. I don't have a date just yet for when it's returning, but it's on its way. So if you're interested in learning about not only the basics of C# code inside Unity, but how to use that to integrate with the FMOD API, this might be a good bet for you. So if you want to learn more about it, I'll have my website linked underneath this video in the description. And there you can also sign up to the newsletter where I'll be announcing the release date first, once I have it, pinpointed and exact and ready to go. For now, I only have a date for the release date, which will be the 5th of August on Monday. And I'll be announcing the release date rather on that date through the newsletter, which you can sign up for here. But enough of that, let's have a look at our sounds in our game kit. Okay, so before we have a look at our looping sounds, the first thing we need to do is quickly add a few one-shots that I actually missed in the last video, which you'll remember we looked at creating a script that we can add to loads of different game objects inside this game kit and use it to trigger one-shot sounds, specifically with any objects that used Unity events. Now, if you missed that video, make sure to check it out, but let's take a look at the first one-shot we missed, which I should have got really because it's at the beginning of this level. It's these doors here. So when you shoot this little switch here, and I think there's one or two more of them in this level, this door will lower into the ground and you'll hear a sound play appropriately. And the way we're going to set up that sound is going to be pretty much the same way we were doing it in the last lesson. So let's have a look at the door object. Okay, so each door in this game has a few child objects associated with it. As you can see here, this is the door I've got selected, but the corresponding object is already under the ground. Now, I could place the sound here, and it would probably work pretty well, but I kind of want the sound to follow the door as it sinks into the ground. So if we click on the object door sprite, we can see that that is actually the door itself. So this is what's going to move into the ground, so I've decided to add the trigger audio script we made in the last video to it. So now hopefully the player, very slightly, but hopefully they will, notice that the sound they're hearing is moving along with the door that's moving into the ground. So just like last time, I selected the event I wanted and left it at that because that's pretty much all we need to do. Then we need to find the Unity event that's going to trigger our FMOD event to play, which for us is this switch here. So as you can see here is our Unity event, which will activate whenever a bullet or an object of the bullet layer, which is obviously one of the bullets that the player shoots, activates the trigger area that's attached to this object. And inside the Unity event here, we can select all the things we want to happen when that bullet enters it. So you'll remember from last time, if we want to add a new function or whatever to play, we click the plus button, then we find the object that our script and the function inside our script is attached to, which for us was the door sprite, which is here, and then we drag it over into the empty game object box here. Now you can see I've already done that here, so I won't do it again. But once you've done that, you then need to select the script that's containing the function you want to trigger, which for us was trigger audio, and then the function you want to trigger, which for us was play one shot. Remember, this is the function we created last time, which plays whatever FMOD event we selected inside Unity's editor. So now whenever this bullet or a bullet from the player enters this little switch, the door drops down and we hear the appropriate noise, which actually I just realized I haven't even played you yet. So let's quickly play you the door opening sound I made. It's a combination of the door opening audio file and small stone door opening, because I felt like it wasn't quite long enough to fit the animation, and whilst I could have probably made my own sound, I've just thought that will save some time and use the assets that come with the 2D game kit. So this is what this event sounds like. There you go, pretty simple stuff, and that plays both for, let's go back to Unity, for this door, and I think there's one more door in this game. It's here you go. So just like last time, there is a switch, this time it's a little bit higher, and the same thing happens. When this switch is shot, the Unity event will trigger the play one shot function that's inside the trigger audio script attached to the door sprite object. If I click on it, There we go. To play the appropriate event. Now, whilst you can't see them, there is some little platforms hidden in the ground here. Here we go. So these little platforms, they trigger when these big crates, if I zoom up a bit, these crates here are pushed, fall down this chasm, or whatever you'd call that, and hits this switch here. So again, we need a sound for it, and it works the exact same way, as you can see. I've added the trigger audio script. The switch has another Unity event, which activates when something collides with its trigger area. And I've told the bridge sprite to trigger a play one shot. There's actually two. So this switch will trigger the little bridge to pop out here. But there's also one up top here that opens. And that's for the player to walk across. And whilst our camera object, which remember also has the ears, our studio listener component, basically the ears of the player, will be down here and probably won't pick up the sound of the bridge. I've added a trigger audio script to it anyway, just, to be thorough. So let's quickly go back to FMOD. Let's find the platform opening function and, not function, event, and play that for you quickly. So that's just a one shot using the small stone door open sound. Now for most of our sounds, I've had to change the min and max distance for both the platform opening and the door opening events, because remember, if we go back to Unity, like I just said, the ears are not the player, wherever she is here. Our ears aren't coming from Ellen, they're coming from the camera object, which is like zoomed out a little bit. Remember, we've got three axes. We've got the X going from left to right, got the Y going up and down, and then we've got the Z axis, which goes kind of forward and back. I can't really demonstrate that with the mouse. But the camera's on the Z axis, and there is some distance between the camera and all the sounds that are triggering inside the game. So that's why if we were to, let's say, go back to FMOD, let's say the player was right on top of one of these doors. If we had the min and max distance set to like 0 and 10-ish, oh, I was way off there. There we go, 0 and 10. Let's say the distance between, or let's say that the camera is a distance of 10 units away from the sound source. Whilst the player object, Ellen, whilst they might be on top of the sound, and you'd expect to hear the sound because of that, the camera's far away, and so the sound will sound really quiet. So that's why we have to bear that in mind and kind of adjust the min and max distance appropriately. And that's pretty much it for those two one-shots we missed. If I missed any more, I'll address them in another video. But now, let's have a look at those looping platforms, starting with this one here.
Okay, to quickly demonstrate what these sound like in game, I've got the game running, and as you can see, I'm about to step on this pressure plate here. When I do, the platform will start moving to the right and to the left and to the right and so on until I move off of the platform. So let's do that now. So there you go, that humming is what we're after. We want it to play so long as the platform is moving. So if I walk off this switch, platform stops moving, we stop hearing the sound. The way this is working is basically I've written a script that checks the coordinates of the game object, and if it's different on the current frame than it was on the last frame, the platform's obviously moved, hasn't it? So therefore we check to see if we're playing our looping event, and if we're not, we start playing it. And then once the coordinates of the current frame and the last frame match, that must mean we're not moving. So we tell our event to stop playing. That's kind of the gist of how the code works. But before we have a look at the code, as always, we're going to start in FMOD and have a look at the event I've designed for it. Okay, so this is the event. It's called Moving Platform, and it's a 3D event. Now, as you might be able to straight away notice, it loops. It's a loop region. But also we've got a single instrument playing the moving platform loop audio file that comes with the 2D game kit, but I've set it to asynchronous and I've told it to loop infinitely. Reason why is because I want this audio file to play, asynchronously from the timeline cursor of the event. The reason why is because I've used the FMOD, if I can find it, the FMOD start offset feature. Now what this does is allow us to set a position along the region in question, which for us is this one here, where we want the cursor to start playing if it's asynchronous. This means that you don't have to start it always from the beginning. You could start it maybe from the middle, from like halfway in between the middle and the start, wherever you want to really. It ranges from 0 to 100%. So obviously if I set it to middle like I have done, it's going to play from the middle.
But what I've also done is I've added some modulation, as you can see here. So if we take a look at the modulation, you can see that I've set that to 100%. So it's a random type of modulation, which means that instead of always playing from the middle, it will now start from anywhere. Each time you play this event, it will start a different position. And this is just a nice way to add a bit of variation if you've got a looping sound that doesn't have to start at a particular place. You could do this and have it start somewhere random so it sounds a little bit different each time. It also means that the chances of two platforms moving at the same time, having their sounds kind of overlay and create that weird sort of double up sound where they sound a little bit delayed but not really, and it's a really jarring effect that it can have in games when you've got two sounds of the same thing playing at the same time. This kind of helps prevent that because both those events, even though they've started at the same time, will be told to start from different positions. So if I quickly play you the event and demonstrate it. Okay, that was that was quite bad because the cursor started at the same place as the timeline cursor. There we go. So you can see it's not only independent from the timeline cursor, it will play anywhere on this region. If I play again, there you go, started from the middle, play again, start from the beginning, and so on. We might have, I can't remember if we've looked at this before, but if you're interested, that's how you can tell a region to start from anywhere randomly. Now that's one of the key features of this event. The other is the fact that I've limited the amount of instances of it that we can hear in FMOD at any given time. The reason why is because there are a few moving platforms in this game, and if the player's really far away from a few of them that are moving on their own, so I showed you that one earlier where it was bound to a switch, but some of them just move independently of anything. If the player's really far away and outside of this min and max distance attenuation graph, say on the graph the player's like here and they won't hear them, we don't really need the event to be playing because this is just the CPU is doing all this work playing an event that's not getting heard by the player. So it makes sense for us to limit the amount of instances of this event that can be played. It also helps, let's say, for example, you had like 5 moving platforms in one scene and they're all really close to the player. Well, that's a lot of looping sounds, and to be honest, the player's not going to notice if 1 or 2 of them are missing. In fact, that's probably more beneficial than having them all play, because that can muddy up our mix and not sound great. So even if there's loads of platforms, close to the player, it's a good idea to limit the amount of instances of the event so that, the mix isn't muddied up. So the way we do this is obviously by setting a limit to the maximum amount of instances. As you can see, I've chosen 3. What I've also done is set a stealing option. Now, I've talked about this in a previous video. I'll have linked in the corner. But basically, let's say we've got, because in this level, there's more than 3 platforms. So let's say 4 of them have been told to play. Not at the same time. 3 of them are playing, and then a 4th one comes along, and by our script, it's then told to play. Maybe the player's just stepped on a switch and now it's playing. Well, the max amount of instances is 3, but now 4 have been told to play. So which ones do you play and which ones do you don't? Well, this is where the stealing option comes in. You can say if you want the oldest one playing to stop playing, or the quietest, or the furthest, which is what I've gone for. So out of those 4, FMOD's API will check which event is the furthest away from the player. Now, by the player, I don't mean literally Ellen, the little character in here. Again, it's taking into account where the FMOD Studio listener component is in Unity, which, as I just mentioned earlier, not that object, it's attached to the main camera, as you can see here, which again is a little bit far away from the player on the Z-axis. So depending on which platform is furthest away from the camera, that's the one we'll tell to stop playing and let the other 3 play. Now, if you don't mind, I'm going to quickly kick my dog out of my room because he keeps snoring in the background. I don't know if you can hear that. Vinny! Out you come. Okay, so I think that's everything to do with the FMOD event. Now let's take a look at the code that's going to be playing it. Okay, so in our scene, there are a total of about, I think, 9 or 10 different moving platforms. If I highlight them all here they are in the scene. So some of them are just going to move constantly as soon as the game starts. Others need to be told to move by a switch or some other component that the player has to interact with. So that's something for us to bear in mind. What I've done is I've highlighted them all and clicked the Add Component button, which allows me to add a script to all of them at once, which is very handy. As you can see, that script is called Moving Platform Audio. So what we're going to do is open it up and take a look at it. Okay, so this is a pretty simple script to get your head around if you've watched some of the other videos, because it uses a lot of the other kind of functions and techniques we've already looked at. But let's start at the top of our class and have a look at the variables we've created. So we've got two variables of the vector-free data type, which means they're going to hold free float values, one for the x, y, and z coordinates. Now, as I mentioned earlier, we're going to use these to work out the difference between the position of each platform during the current frame and the position it was in during the previous frame. Hence why one's called pos, short for position, and one's called old pos. Next, we have an FMOD event instance, as always. This is what we're going to use to store an instance of our FMOD event moving platform inside of. Now, don't forget that this script has been attached to about 10 different objects, so we're going to have 10 instances of that, whoops, wrong button, of this instance created as soon as the game starts, and they're all going to be stored in their own event instance variable called platform loop. Now, of course, like I said earlier, we've limited the amount of instances that can be played at one time to 3. So whilst we'll be creating 10 on the first frame, which I'll show you in a second, we are going to have to bear that in mind as we continue coding our script. Next, I've created a variable of an enum that comes with FMOD called Playback State. I've talked about this before. This is a way that you can check to see what your event is doing for your code. Is it playing? Is it stopping? Is it starting? Has it hit a sustain point on the event timeline, which we've looked at? I think in one of the lessons we looked at the pushable object, we used that for. Really handy, and we're going to use that to check to see when the event, or sorry, not check to see when it's playing. We're going to check to see if it's playing before we tell it to play, because obviously if it's already playing, we don't want to tell it to play again. We'll make things sound messy. So yeah, I've called that PB state as I always do for short. So only 4 variables, nice and easy to keep track of. Let's have a look at how we use them in the script, starting with the void start function, which, as we know, happens on the very first first frame that the game is run. First thing we do is create an instance of our event moving platform. So I'm using the event path. I don't know if you saw in FMOD, but I've put this inside of my interactables folder, inside the sound effects folder. So that's my event path. And now by accessing the platform loop variable, we can access that instance. Again, remember, times that by 10 because this script has been attached to 10 objects. Next thing we've done is set values to the pos and old pos variables. So whilst they represent the current frame and the last frame respectively, this is the first frame and there hasn't been a previous frame yet. So we might as well set them to the exact same value. Now, the way we do that, like I said, we want these to represent the position coordinates of the platform. So to access each, platform's coordinates, we use transform.position. Transform is a short way of us getting the component transform of each platform. Another way of writing it would be like this. We'd write get component transform with a capital T to represent the transform reference data type. Then once we have access to the transform component, we want to specifically access the coordinates under position. Let's go back to Unity. So whatever coordinates, in fact, let's click on one and not all of them. There we go. So whatever coordinates are in this section here. Now this works because position is also a vector free. If we just left it as transform like that, we'd get a little error because transform, just get component transform on its own, doesn't match the same data type as our position variable, which as we know is of the vector free data type. This is of the transform data type. So that's why we need to make sure we're saying specifically we're after the position, because position is a vector free. Okay, so both of these now have coordinates for each platform that has this script attached to them. Remember, each platform has its own pos and old pos variable attached to it, each one having the coordinates of that platform. Okay, so that's what's going to happen on the very first frame the game is run, but now it's time to have a look at the fixed update function, which I think I've mentioned before in a previous video, but I'll mention it again if I haven't. This happens 50 times a second. Now, if we were to just use the plain old update function, that would run 60 times a second, or every frame that is run per second, whether that's 60 or 30 or 90 or whatever. But because the update function is locked on to, trigger every time a frame is run, and we know that frames can change depending on the performance of the game, It's very unstable, so sometimes it's not always the best option. Sometimes it will run 60 times a second. Sometimes it will run 2 if the game suddenly, dropped in frames. So I'll explain a little bit more in detail why in a bit, but we're going to be using fixed update, which runs at a more consistent 50 times a second. Okay, so next thing we're going to do is use the set 3D attributes function to make sure that we are telling our FMOD API that our event is a three-dimensional one, and therefore we want it to, drop in volume and increase in volume depending on its location to the studio listener component and create a sense of three dimensions in the game. Now, the other command or function we use to do this is called attach instance to game object. The reason why I'm not using that though is because that you need to use with whenever you tell the event to start. Normally, it's the easiest one to do because, unlike this, you don't necessarily have to have it triggered every frame that the event is playing, whereas with set 3D attributes, you do. But because this script, don't forget, is being used for both platforms that will move straight away, and therefore we need to hear audio for straight away, but also platforms that will move when the player tells it to move, when they interact with them, and therefore we don't know when they will play. So it's a little bit easier for us to just constantly tell it every frame where we want to play the event using set 3D attributes. Now, I think we've mentioned this function once before in this series, but I'm going to mention it again because I don't usually talk about it. First of all, you need to call the event instance you're using. For us, is platform loop. Then you write dot set 3D attributes, as that's the function. Then you need 2 brackets, and inside the brackets, you need to call another function. You need to call the class runtime utils, which is another FMOD and Unity class that comes with the API, and use another function called 2 3D attributes. Then inside the brackets of that function, you need to feed it the position that the game object is currently in. Remember, we are calling this function every frame, so that's going to update if we just put transform, as we mentioned earlier. That gets the transform of the transform component that's attached to the game object. That's obviously going to change positional coordinates as the game object moves every frame. So we can just write transform here. Luckily for us, this function doesn't require the specific vector free like our variable we created earlier does. It literally just needs a reference to the transform component. So we just write transform there, that's nice and easy. Then we also need to get any rigid body components that are attached to the game object. Specifically, rigid body 2D components, because this is a 2D game and Unity has different types of rigid bodies for 2D and 3D games. And this is because sometimes objects move depending on the physics system that Unity has and not necessarily just being told to change coordinates. So it needs to take into account both of those components. Even if your game object doesn't have a rigid body attached to it, I think you still need to enter get component rigid body for this function to check. So let's go through that one more time because this function is a little bit confusing. So you call the set 3D attributes function, which has 2 brackets. Let's try and highlight them both so you can see them. There we go. So this one here and this one here. Inside those brackets, we need to give it another function, the 2 3D attributes function, which we access through the runtime utils class, which we access through the FMOD and Unity namespace. Inside that function, we need to feed it references to the transform component we'd like to play our audio at, and any rigid body components that are attached to that same game object that might affect the position of the game object. So to sum up, we have a function that within it has a function that within it has references to the transform and rigid body components attached to the game object you want to play your event at. Great, so now that we have told where our event is going to play, we now need to tell our event to take its playback state it's in and store it within inside the PB state variable we created earlier. And we do that with the get playback state function. Now, unlike the set 3D attributes function, this one, thankfully, is nice and simple. All you need to do inside the brackets is tell it to output whatever state our event is in to the playback state. That way we can then access this variable here, let's say, I don't know, in a debug.log command, and it will spit out one of 5 potential states, which I mentioned earlier: playing, played, stopping, stopped, or sustained. Now we need to make sure we're also doing this every frame because obviously the state can change at any frame. Let's say we called this function in the start function during the first frame when the event wasn't playing. If we then played the event and checked our playback state variable, it would say stopping because the last time it got a playback state from our event, the event wasn't playing during the first frame. Even though it's playing now, it hasn't recently been updated. So that's why we need to make sure this is called every frame. Okay, so now we're pretty much set up. It's time to get into the meat and the bones of how this script will play our looping sound. So the first thing we need to do is update the position variable, again, to whatever position our platform is now in. Again, this is going to be running every frame, so every time the platform has a new position or a new set of coordinates, it will be stored within this variable. Next, inside an if statement, we're going to check to see if the coordinates within the pos variable are the same as the old position coordinates. Specifically, we want to check to see whenever they don't equal each other and that they are different. Like I said earlier, if they are different, this means that the platform must be moving, which means we want to check to see if our event is playing or not. Now let's say the platform has moved. So during the first frame, I don't know, the coordinates were 0, 0, 0 for both of them, and we set them both to 0, 0, 0. Well, now we've updated the position variable to the new coordinates of the platform that it's at during this new frame. And let's say that's 0, 0, 1 for simplicity. Well, we haven't updated old pos just yet. That's still 0, 0, 0. So we can check it with pos, which is now 0, 0, 1. So if those variables don't match, which in our little example they don't, we can move on to the next if statement we created inside the body of the old one. This, we are doing a similar thing. We're checking the state that's stored inside of PB state. Specifically, we want to check to see if it's been assigned to the playing state. Now, as mentioned earlier, that will be done by get playback state and will only be set to playing if the event has been told to play. So far in my little example, it hasn't been, and again, that's what we're checking for because of the exclamation mark combined with the equals, this operator here, that's checking to see if two conditions are not the same. So in our example, they're not the same, so we move on to the result of that if statement, which is us telling the event to play using the start function. Again, that's a function that comes with FMOD API. Next, we go down to this else if statement. Now, this is designed to check to see when the platform isn't moving and has stopped. As you can see, instead of checking to see when these two variables are different, we're now checking to see, get out of the way, we're now checking to see when they are the same. If they're the same, we know that the platform isn't moving anymore, and therefore we want to stop our platform from playing. Now remember, this is being run every frame, and the platform might have stopped frames ago, and we might have stopped the event from playing ages ago. So we also need to check, which we are doing by using the two ampersands operator, which allows us to check for two conditions in an if statement. Again, just like last time, this is us checking to see if the event is playing or not. This time we're checking to see if it's playing rather than it's not playing, because obviously if it is playing, we want to stop it. So if the platform is not moving, which we check thanks to this section here, and if the event is playing, which we check with this section here, we need to tell our event to stop, which is what this line of code does here. We use the stop function, again, an FMOD API function, and then we need to feed it a stop mode constant. Again, stop mode is another enum. We've mentioned enums before. They're basically just a collection of constants that you can set, one of which for us, in the case of this, FMOD enum, you can either set the stop mode to either allow fade out, which allows any AHDSR modulators, or any modulators really, you've added to your event to fade out, or the other option is immediate, which basically tells it to stop immediately regardless of any fade outs you've added. Which actually reminds me, that's something I didn't mention about my event. I did add a AHDSR modulator somewhere. There it is. Okay, so for audio track 1, if I open it up here, I've set an attack and a release to 400 milliseconds. So the sound will fade in and out over 400 milliseconds. So I need to make sure mine is set to allow fade outs. Now, during our little example, we've only just told our platform to play because it's moving. So the else if statement would get checked, and sadly, the conditions have not been met. Our platform is moving. Therefore, this line of code won't be called, and our event will continue to play. Last thing we need to do is, now we've used both the old and the current position variables, in every way we needed to, we now need to update our old position variable. Now that we've done everything, we can assume that it's the very end of the frame. Therefore, we want to set old position to match position so that when the next frame rolls around, we'll have a reference of the coordinates our platform was at during the previous frame. And that's kind of the gist of how this current frame, previous frame little system works. Before you do anything, you set the current frame's position to whatever you want. Then you do everything you need to do with the old and current variables, which is all of this section. Oh, let's get that right. Which is all of this section here. And then once you don't need them anymore, you update the value of the old frame. And this doesn't just have to be about the position of an object. We've also done this either with the player or with the pushable boxes in this game. I can't quite remember. One of them, we did the same sort of thing to check to see whether, or to see if the object or the player was grounded during the current frame, and to check to see if they were grounded during the previous frame, which helped us for playing back like landing sounds and stuff like that. So it's a really easy system once you kind of understand it. It comes in handy a lot for triggering audio. I don't really we need a name for it really, like the old and current frame system. But yeah, really handy. Let me know if you have any questions about that, because I really want to hopefully get this across to you. But anyway, now that that's done, everything with our fixed update is done. The last thing we need to do is release our event instance. So let's assume that the game's just finished, or the player's just exited the level rather. All of our objects are now being destroyed by Unity, or unloaded. And Unity is about to load in a new scene. Well, we also want to destroy all the instances of our events. We don't need them anymore. We're not going to turn them to play. We need them to be released. So whenever our objects are destroyed, which we can check with the onDestroy function, we tell our event instances that are stored inside platform loop to be released. Then let's say the player enters a new level with more platforms that move. We'll create new ones for those platforms as a start function will be triggered again. And yeah, that's pretty much everything to do with this script. It's pretty simple compared to some of the stuff we've written previously in this series. But there is a little bit of not difficulty. There's a few areas of understanding that hopefully I've made clear to you guys. Like I said earlier, let me know in the comments if I missed anything or didn't explain anything as well as I could have. One final thing I will mention is the reason why I've used fixed update instead of update. And I think the best way to explain why I've done that is actually by changing the code slightly and giving you guys a quick demonstration of what was happening to me with some of the platforms that move on their own. Or when I say on their own, they move without needing the player to trigger them. They're just moving from the start of as soon as the level opens. So what I'm going to do is create a debug.log command. I'm just going to write stop in it. So what I've done is I've written a string and I've just written stop. So whenever this what do I say elf? This else if statement, whenever the conditions inside it are true, i.e. when the platform has stopped moving and we need to tell our event to stop playing, we're not only going to tell the event to stop, but we're also going to call this debug.log command to display the stop message in our console tab in Unity, so we can check to see when this has been called. Then what we're going to do is set this function back to update. So now instead of being called 50 times a second, it's now going to be called on every frame that's run. It could be 60 times a second, it could be 2. Let's save that, let's jump into Unity, and I'm going to, I guess, play the scene and show you what the issue was. Now, hopefully you can hear that, but basically, we've got a moving platform here, one that's told to start straight away and just keep going. And we need the looping sound to play constantly and not stop. However, you can see in the console tab here, there we go, it's being told to stop. This debug.log command is coming from this platform here. Now, we do have other moving platforms in this scene, so could those, again, we've attached the script to all of these platforms, so potentially these messages could be coming from them as well. There's a way we could have set it up so we know it's coming from this one specifically. Either way, it doesn't matter. The point is we should not be getting any stop messages coming up at all. None of our events should be told to stop. Either they're not playing because we haven't activated them yet, such as this one here that has a switch on it, or they are playing because they've been told to continuously play whilst the platforms continuously move. So what's happening here? Why are some of them being told to stop? Well, I suspect the reason why is because in some instances or in some frames, even though that we can see that the platform is moving, the coordinates that are being stored within pos and old pos happen to be the same. Now, that might be because we're not running at a high enough frame rate. That might be because the platform is moving so slow. Sorry, that might be rather because the frame rate is so high that the platform hasn't moved far enough for the coordinates to update. Therefore, the frame that the platform currently is on now, the position of it is the same as it was during the old frame. Therefore, our script assumes that the platform has stopped and then tells our event to stop, which is not good. So one or two fixes we could do. One thing here we could do is tell our platform to speed up a little bit. That's not really something we want to do, though. We're not, we don't want to change any of the gameplay design elements. We want all of our audio to work around it. So that's why I've used fixed update. We don't have that issue. Because the function's being called consistently 50 times a second, we don't have these jumps in frame rates where they go so high that the difference in position of the platform is so minimal that our code thinks it hasn't moved. So whilst this is a pretty fairly and quite a nice way to set up looping sounds with anything that moves, that is a little bit of a flaw with it. In fact, I suspect that if this platform was moving any slower, or rather if it was moving so slow that, 50 times a second wasn't enough was too many frames for it to, update the position, we'd have the same issue with fixed updates. The difference between the position of the current and the old frame would be so minimal, the function would be told to stop, or the event would be told to stop, rather. So that is something to bear in mind if you have this issue where you're just getting loads of unwanted stop messages and your events sound really stuttery like mine does. Let's see if I can get closer so you can hear it.
Yeah.
Oh, I guess we're also having frame rate issues as well. There we go. So we got a few unwanted stops in there. So that's something to bear in mind. But on the whole, that's pretty much it. And I'm just going to quickly change mine back to fixed update and save it. And don't get rid of that because I don't need that anymore. Great, so thank you very much for watching. I think that's everything I wanted to mention in today's video. Now, if you want to pinch this script, maybe adjust it for another project, or if you are following along and you want to add this to yours, you can do. Let's go back to my website. I'll have my website linked under this video, where you can get this script and any other script from my old videos that you need. Someone recently pointed out that in my old videos I hadn't updated the links, so they were going to my old... Ooh, I'm all zoomed out. They were going to my old website, which doesn't work anymore, so they couldn't get the scripts, but now you can. The link will take you to this page here, C# scripts, and whilst it's not loaded yet, oh, there we go. You can see, we've got all the videos that I've uploaded to this YouTube channel, along with all the scripts that were mentioned or designed in it. So I'll update it for this video, and yeah, you can copy this script and use it for yourself. But yeah, that's pretty much it. Thanks very much for watching. As always, if there's anything FMOD Unity or even sound design and audio related you'd like me to look into and explain for you guys, I'd be happy to do so. Just hit me up. I don't say that. Just give me a message in the comments section and let me know what you're after. I'll be happy to take a look at it for you. And if you're interested, check out the FMOD and Unity Essential course, or keep an eye on it for you. It's a big course that hopefully gives you everything you need to approach a big project with another team of developers in terms of indie stuff, so you can implement the audio with FMOD using Unity Engine. So hopefully that will go down well. And if you want, you can follow me on Twitter, or I might even try getting an Instagram up for this little page. Let me know if you would like to follow me on there. I can stick, screenshots of whatever I'm working on there. But enough rambling from me. I've been Henry Scott, and as always, thanks very much for watching.